Okay, we have a very last topic for the CFE review, which is probability, which is the topic that we discussed most recently in class. So hopefully this has been the freshest for you and the easiest to complete. Our unit was called Probability and Statistics, so I just wanted to let you know that the statistics portion is something we did not get to. It will be on the CFE, but again, the CFE is so heavily rounded, it's so heavily curved that not understanding the statistics question will not affect your final grade. So please don't stress when you see statistics questions and don't know how to answer them. It's going to be totally fine. So we're just going to go ahead and look at this topic of probability. Our first step is to list the sample space for some scenarios. Remember, the sample space is just a list of possible outcomes. It says to use proper notation. The notation is S equals, and then the curvy brackets. And we're going to make a list of all the possible outcomes we could get. If I roll a 6-sided die, I could get numbers anywhere from 1 to 6. So I'm going to go ahead and list those numbers. I could get a 1, a 2, a 3, a 4, a 5, or a 6. And that's it. The sample space for drawing a marble from a bag that contains 2 red marbles, 3 blue, and 1 white. If I reach in and draw something out of the bag, I could get a red marble. I'm going to use the letter R. I could also get a blue marble. I'm going to use the letter B for that. I could also get a white marble, which is the letter W here. So that's it for that guy, and it should be S equals for proper notation. So it's just a list of the possible outcomes. And for tossing a coin, if I toss a coin, I could get heads, and I could also get tails. Those are my 2 options. And that's it for the sample space. It's just a list of the possible outcomes that we could get from a scenario. Up next, we have a Venn diagram. We talked about these just a tiny bit after our probability quiz. Again, it's heavily curved, so if you don't understand a Venn diagram question, that's okay. There are 91 students total in the 8th grade class. 68 have signed up for art, 31 for band, and 18 have signed up for both. Please remember, when you're making a Venn diagram, it's easiest to start with the both category. So 18 are in both classes. Now, it does say that 68 people have signed up for art, but inside this art circle, I already have 18 students listed. So if 68 total has signed up, then there are only 50 remaining who are taking only art. So I have to do 68 minus the 18 I've already got in that circle. The same thing's going to happen when I take a look at the band students. I already have 18 students listed in this band circle, but there are 31 total who have signed up for band. So if I do 31 total minus the 18 that are already in that circle, there are 13 students who are in only band. And now if I compare the total number of students that I have here to the total number of students altogether, I have 50 and 13 is 63 plus 18. I have 81 students listed here in my Venn diagram altogether, but there are 91 total. That means there are an extra 10 students who have not been represented by the Venn diagram. So 10 more students who have signed up for neither art nor band. They're in other classes. Oh, and it also tells me that right here. I should read the problem. 10 students are in neither. Okay. So the sample space is the set of all the 8th grade students. Let the students be A for art and B for band. And we want to find out, what is the intersection? Not the intersection. This U symbol means or. So what is the number of students who are in either art or band? Now, it doesn't say the probability. It doesn't say the probability of A and B. It doesn't say that part. So we're not actually going to make a fraction here. We don't have to create a probability. All we have to do is find this number of students who are in art or band. If we do that using the addition formula, we would use the totals from up here. 61 plus, that's the number in art, plus the number in band, 31, minus the overlap, 18. That would be if we're using the addition formula. We use the totals. But if we're using the Venn diagram, we get the exact same answer just using the totals from the Venn diagram. 50 in just art, 13 in just band, and 18 in the overlap. Either way we do this math, we get the same number, and the number is 81. And it's actually much easier to find because if they're in art or band, they're everybody except these neither students. All right, up next it's asking A and B. This N means and. So what is the A and B? So the students who are in art and band. That's just asking for this intersection right here, the overlap. And that answers that there are 18 students in both art and band. Up next, it has this notation, negative A or B, which means A or B complement. This means how many students are in neither art nor band. How many students are not in either art or band? And the 10 is the number of students who are not taking either one, so that would be the number 10. That's it for this question. Remember, none of this was asking about probability. It was just asking about the number of students in each scenario. Number 55 here says that we have a prize wheel divided into 12 equally likely spaces, and they are labeled 1 through 12. Event E is landing on a multiple of 3. Event F is landing on an even number. The easiest way to work on this problem is to actually take a look at the sample space, which is, again, all the 12 spaces labeled 1 through 12. So I'm going to take a look at the numbers 1 through 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I'm going to look at these numbers, and I'm going to try and figure out what E is and what F is. E is landing on a multiple of 3. I'm going to underline in red for landing on a multiple of 3. So 3 is a multiple of 3, so it's 6, 9, and 12. Up next, we have F. I'm going to underline using green. Event F is landing on an even number, so 2, 4, 6, 8, 10, and 12 are all even numbers. Now, it says for E and F to be independent, find what the multiple of the probability of E and probability of F to equal. So that's basically just asking me to do this math and round to the nearest hundredth. So I'm going to create the probability of E. The probability of E is asking me how many times does E happen, how many multiples of 3 are there out of the total sample space. So I have 12 total spaces in this spinner, in a wheel. And how many of them are multiples of 3? So I have 1, 2, 3, 4 things underlined in red, so that's 4 twelfths. We have to multiply that by the probability of F, which I did in green. So out of all the 12 spaces, how many of them are even numbers? 1, 2, 3, 4, 5, and 6. So this is 4 twelfths times 6 twelfths. If I go ahead and multiply that across, 4 times 6 is 24, 12 times 12 is 144, which would be an unreduced fraction, but it actually wants my answer as a decimal, the nearest hundredth. So in the calculator as a decimal, that is 0. I didn't write it down here. Let me go ahead and calculate that real fast. 1 divided by 6, 0.166667. To the nearest hundredth is 2 decimal places, so 167 rounds to 17, and that's it for that answer. Let's go ahead and take a look at question 56. A couple plans to have children. There are 8 different types of combinations of girls and boys that they should be able to have. They want to have 3 kids. So A is the event that the first child's a girl. So I'm going to use red and underline each scenario where the first child is a girl. So here, they're all girls, so the first one's a girl. Here, the first one's a girl. Here, the first one's a girl. And this one, the first one's a girl. Up next is the event that the second child is a girl. So that's a completely different scenario. I'm going to use green to underline that one. I don't care what the first child was now. I'm going to go ahead and draw this line on top. I'm going to overline the second child being a girl. So here, where they're all girls, the second letter is G. Here, the second letter is G. This one is a boy. This one is a girl. There's another boy. Here, the second child's a girl. And that's it. So our first question is, what's the probability for event A? So out of all of the possible scenarios, 1, 2, 3, 4, 5, 6, 7, 8, out of 8 different combinations, how many of them had the first child be a girl? So that's the red. 1, 2, 3, 4 out of 8. Round to the nearest hundredth. That's 0.5. If you want to put the hundredths place in there, it is a 0, or 0.5 is acceptable since it was exact. What is the probability of B? So out of all 8 scenarios, how many of them had the second child as a girl? 1, 2, 3, and 4. Again, so half of the scenarios had the second child as a girl, so 0.5 or 0.50. And up next, if A and B, the event that both the first and second children are girls, is 25%, are these events independent of each other? So A and B, that's two separate things happening, having a first child and having a second child. We should multiply these probabilities together. 0.5 times 0.5 is 0.25. So that kind of is just a given. The real question here is, are they independent? And we don't actually need to know the probability in order to know if they're independent. All we need to do is look at the scenario. Having multiple children, do the genders depend on each other? So are they independent? Yes. The gender of the second child does not depend on the gender of the first child. It makes no difference. What first child you had, the probability for each child is always 50%. So the gender of the second does not depend on the first. There we go. All right, up next, question 57. This is a two-way table. Let's go ahead and take a look. Recent survey, 9th and 12th graders studying abroad. So the first thing we have to do is complete the table before we can really answer any questions. Now, it's fairly easy to complete the table. All you have to remember is that this total column just adds up the two previous columns. So something plus 38 is 113. If you use subtraction, that number is 75. 64 plus 102 should give us this number, which is 168. 43 plus some number is 110. If we use subtraction, we can find that 67. And for the totals on the bottom, all we have to do is add up all of the rows that came above. So this number down here is 389. We add up 113, 168, and 110. 75, 64, and 43 added together is 182. And 38, 102, and 67 added together is 207. Now that we have the table filled in, we can answer the question. According to the data collected from the survey, what is the probability that a 12th grade student wants to study in China? So the important thing to notice here is that it says a student. We're making one choice, and we're trying to choose one person who is both in 12th grade and wants to study in China. That is an intersection. We're trying to figure out where 12th grade intersects with China, and that's right here with the number 67. So there are 67 chances for one student from 12th grade to also want to go to China. That's 67 out of the total population of students. So a student out of the entire study. There were 389 people asked. That gives us our probability. It says to round our answer to the nearest hundredth. So in the calculator, we get 0.172, which rounds to 0.17. We have one question left for our review. How exciting. We have another two-way table here. It says 100 students were surveyed about their preference between dogs and cats. So here's our two-way table. Find the probability that a random selected student, a student, one choice, prefers cats or is female. So this is the addition property. This is the addition rule. So we have to do the probability of event A plus the probability of B minus the probability of A and B. So we have to do the addition rule here. So a randomly selected student prefers cats or is female. So prefers cats is our first probability. So here's prefers cats right here. There are 36 students who prefer cats. Probability is always out of the total, the grand total, unless it says the word given. So there are 100 total students that were surveyed. So that's probability A. Let's take a look at probability B. Out of the 100 students, how many students are female? So that's this column here. There are 52 students who are female. And we have to subtract the probability that they are both. That means that they are female and prefer cats. That's where this column intersects with this row. That is the number 26. So there are 26 people who are both female and prefer cats. So all we have to do here is add the numerators and subtract the numerators. So I'm going to do these numbers first. 36 minus 26 is just 10. Plus 52, that gives us 62 out of 100. And it says to round to the nearest hundredth. 62 out of 100 is 0.62. And that problem's all finished. We use the addition rule. That's it for our CFE review. Good luck studying, and I will see you on test day.